That's kind of why did the scientist disconnect his doorbell? Why did the scientist disconnect his doorbell? He wanted to be in the running for the Nobel Prize. All right. For the next 3 weeks or so. Okay, for the next 3 weeks, you don't have to bring your textbook. Okay? It says chapter 9, sequencing series, which is what the textbook covers, but I don't like how the author does it at all. So I use the Stewart textbook. And these problems, this packet is your homework packet, and all the problems came from the Stewart textbook. So you need to take good notes, because the notes are on the board. But I also have copies if you're going to be gone certain days in the notes. Okay, now, do we have any procrastinators in here? Okay, the procrastinators always have trouble with this section. Okay? Because we do section 1. If you look at the syllabus here, you do section 1, and then you take the quiz. And you take the quiz when you're ready. Then we do section 2, and you take the quiz 2 when you're ready. Now, the good guys and the good gals take quiz 1, then quiz 2, and then I'm starting section 3, and the procrastinators still haven't taken quiz 1. So you don't want to let yourself get behind. The point is, we have a guideline when you should be taking the quizzes, but you don't have to take them if you haven't mastered the material yet. But don't let it slide too far, because then all of a sudden you get through the whole unit and you're only on quiz 3 and we're finishing the chapter. So, okay? So those procrastinators, work on that. Yeah, the real short quiz. Okay. So,
okay, quick story time. We've been doing now. And we had
so section 1 would be, these sections will not coincide with chapter 9 of the book, because I don't believe there's 7 sections. So this section 1 corresponds with section 1 problem. The chapter involves sequence and series. The first section deals with sequences, and then the rest of the chapter deals with series. And the first 2 or 3 sections is sort of like pre-calculus. You're just learning the skills, and then you start applying it to why we're actually using it, what could we do. So, kind of bear with it. Okay, what is a sequence? A sequence is simply a list of numbers. An example, not example, but just a sub 1 would be the first number, a sub 2, a sub 3, a sub n. That would be a sequence of n numbers. And there's various ways of describing them. One example would be the nth number is described as n over n plus 1. So this would now produce a sequence. When n is 1, the first number would be 1 over 2, with a 1 in for n. The next number in the sequence would be 2 over 3. next number in the sequence would be 3 over 4, and so on. Of course, the last number in the sequence, if we didn't have a value for n, would be n over n plus 1. Another example, a sequence might not have no formula. Example would be the digits of pi. So the first digit would be 1. Next digit would be 4. Next would be, is it 1, 5, 9, you got it? Well, let's see if you were right.
I did. Well, no, I answered. I was like,
I've got it to 100,000 places if you want it. All right, so here's an example. Okay. All right, definition. Let's take the limit as n approaches infinity of a sub n. All right, if you take the limit of a sub n, n is defined by some method, and it gives you an answer, L, or it gives you no answer, meaning infinity. It's either one of those two things. It's either going to give you a number, or it's going to be so big that you can't describe it. It's infinite. So if this happens, the sequence converges, which means it goes to an answer. This particular sequence diverges. An example would be one that converges would be 1 over n, because this produces 1 over 1, 1 over 2, 1 over 3. What's that last term going to be? 1 over infinity if n goes to infinity, which is basically 0. An example of a sequence that diverges would be just the reverse, n. That produces 1, 2, 3, 4. The last term would be n. Very simple example, but there's one that diverges. Okay. Now let's, what does this sequence do? The limit at n over n plus 1. Well, as n goes to infinity, you get infinity on top, and you get infinity plus 1 on the bottom, which is an indeterminate form, but we can deal with it by L'Hopital's rule would be one way. L'Hopital, you take the derivative. Well, first of all, it has to either equal infinity over infinity or 0 over 0. You can't just throw in L'Hopital's rule to get it down. You have to, it has to do one of those two. So the derivative of the n with respect to n is 1. Derivative of that is 1. Equals 1. Therefore, the sequence converges. Another way of doing it would be to divide the top and bottom by n. As long as you divide top and bottom by the same thing, it doesn't change its value. And this would give you the limit of 1 on top, 1 plus 1 over n on the bottom. So now it's okay to plug in infinity because you're going to get an answer. You're going to get just 1 over infinity, which is 0. 1 over 1 plus 0, give you 1 as an answer. So again, either one of those methods would work. The reason I bring that up is you're not always going to be able to just use L'Hopital's rule in what we're doing, so you have to be able to approach it with different methods. Okay, let's try the limit as n approaches infinity, natural log of n over n. Does this sequence converge or diverge? Put infinity, you're going to get the natural log of infinity, which is infinity. So infinity for n, you're going to get infinity. So it's an indeterminate form, so we've got to do something with it. In this case, L'Hopital's rule would probably be the best one. So using L'Hopital rule, what would you get? You would get 1 over n on top, and the derivative of n with respect to n is 1. So you get 1 over infinity, which is 0. So that sequence converges also. All right. Okay, let's get a little tougher. Let's do the limit as n approaches infinity, -1 to the n over n. What's happening to this sequence? It alternates between a plus and a minus. It isn't just going down, it's plus or minus. And so what we can do here is we can use this squeeze or the sandwich theorem. Remember that one? Okay. Is a sub n less than or equal to the absolute value of a sub n? Is that a true or false statement? Yeah. A number is either going to equal itself or it's going to be less if the number is a negative. And this is going to be greater than or equal to the negative of the absolute value. Would you buy that?
Yes.
Okay. So now let's take this here and turn it into an absolute value. So we're basically making it a sub n with an absolute value. Well, if it's an absolute value, what happens to the negative? It goes away. So this becomes a negative, becomes a 1 to the n over n. All right? What is the limit of this? As n approaches infinity. 1 over infinity, or basically 0. All right, so now what are we saying? We're saying the absolute value of this number, the absolute value of that number is 0. What's minus the absolute value of that number? 0. So then the number has to be sandwiched in between them. And what was the number? It was -1 to the n over n, which is what we were looking for. So mathematically, that's the solution. I think the easier solution is just use common sense. If you take a number, it's a concrete number, like -1 or +1, and put it over infinity, what are you going to get? You're going to get 0. Because as long as you have a concrete number on top, whether it's negative or positive, and divide by infinity, you're going to get 0 anyways. Okay, any questions on that?
How is the concrete number assigned to?
Where are you at? Because it's a 1. And you're raising 1 to infinity, so it's either 1 or -1. We're talking about concrete 1, or concrete -1, or concrete 1. It's in one of those, and we're dividing by infinity. Now, if that number on top is growing to infinity, then we have to use something else. Yeah, I was going to say, it isn't all. Okay, here's an example that's not quite cut dry. So let's let yeah, right. Okay, so let's let a sub n equal the number. Let's write out a couple numbers. This is another thing that you're going to want to do often to figure out what's going on. So what would a sub 1 be? Well, the first term of the sequence. 1 factorial over 1 to the first, which is 1. What's the second term going to be? 2 factorial, which is 1 times 2 divided by 2 to the second. Or 1 times 2 divided by 2 times 2. What's a to the third? It's 1 times 2 times 3 divided by 3 to the third, which is 1 times 2 times 3 divided by 3 times 3 times 3. Okay? See the pattern going? So now, what is a sub n? It's 1 times 2 times 3 times 4 all the way up to n. It wouldn't be n minus 1, I don't think, because this is a to the third. That's 3.
Can't you cancel?
Well, we will eventually. And then what are we dividing it by?
N.
In fact, n to the nth, which would be n times n times n times n times n. All right, now what we're looking for is this. What does this do? So look at this right here, and just take this part here. Is a sub n less than or bigger than 1 over n?
No.
Well, I've got 1 over n here. Now, what am I multiplying this by? 2 over n, something that's less than.
And n's going to be bigger than the number on top, so we multiply it. The numerator is going to denominator is faster than the numerator.
Okay, is this true? Is this statement true?
Yes.
Yes, because this thing equals that, and we're multiplying this by a number that's what? Bigger or less than 1? Less than 1, because this is 2 over, let's say, 1,000,000, times 3 over 1,000,000. All these numbers are less than 1, except for the last one. So essentially, I'm multiplying this times a number that's less than 1. So a sub n, it has to be less than 1 over n. Yes, Joe?
What happens if you have n being 1? Well, then because then it'd be 1.
No, because then you wouldn't have any of these. You'd have 1 over 1. So less than or equal.
Okay, because it's to the x.
Okay? So basically, this thing is less than that, and this thing equals this. What does 1 over n go to? What's the limit of 1 over n as n goes to infinity? It goes to 0. So if that goes to 0, a sub n has to be what? Less than or equal to that. And we're dealing with positive numbers, so it goes to 0 also. So what does that tell you about this sequence? It converges. Did you follow that?
Just go over that last part.
Because we're dealing with n's, and n's going to infinity, and we usually start with n either being 0 or a positive number. Okay. All right. You're with me with this here.
Yeah.
I rewrote it like this, and I said, okay, I know something about 1 over n. I know that 1 over n is going to go to 0. All right, how does this thing compare when I put this part in? Well, 2 over n is less than 1, so that's going to make this number here, 1 over n, or a over n less than this, because I'm multiplying this thing by a number less than 1. Okay?
So then, how does that lead you to the conclusion it's
Because 1 over n goes to 0, and a over n has to be less than that, so it has to go to 0 also.
why can't you do something negative?
That was just because we're dealing with positive numbers. All the sequences here, when n's going to start at, n stands for a number of terms. So you can't have a negative number of terms.
Oh.
We're starting with either 0 terms or up to infinity number of terms.
So it's kind of like sandwich theorem with zeros less than.
Right, it's kind of like the same. It's kind of like the same idea as the sandwich, is that we're not actually finding the limit. We're finding the limit of something bigger, and that goes to 0. So then this one has to go to 0. Okay. All right. One last thing I wanted to point out, I think was yeah. Oh, okay.
Does this feel a lot harder than
We'll find it a tough unit.
is the Parker test? Is the Parker test that you did?
Yeah, you'll be.
Yeah. Oh my God. It was like yeah, can we get a tri-Parker test?
Okay, just a quick definition. If a sequence goes like one of the two, if each term keeps getting bigger, it's called an increasing monotonic sequence.